Hi, Professor Jaskell. I had question 16 for the final exam, and that question reads, a population of 1,000 students spends an average of $10, 50 a day, on dinner. The students, the standard deviation of the expenditure is $3. A simple random sample of 64 students is taken. So for question A, first I found the expected value, which was of the sample mean, which is 10.5, and then the sample standard deviation, which can be seen here, which was 3 divided by, which is the original standard deviation, divided by 64. That's just the -2 power, but that's just the square root. Divided by the square root, which is the sample, or n, and you get 0.375. And then since this sample is greater than 30, and the standard deviation is equal to, or no, the sample mean is equal to the standard deviation divided by the square root of n. So therefore, it would be a normal shaped distribution. So then, as for question 2, you can see right here, it's asking the probability that these students will spend a combined total of more than $715.21. So for the mean first, we have, or X bar, we have the $715.21 divided by 64, which is the sample, and therefore you get 11.1752, which is approximately 11.18. And then to figure out the probability, we just do a normal, since it is a normal distribution, we take 1 minus norm.dist in Excel, and then you have 11.18, which is the sample mean, and then 10.5, which is the population mean, and then 0.375, which is the sample standard deviation, and then true because it's cumulative. And therefore you get 0.0349. Therefore, the probability of the 64 students spending more than a combined total of $715.21 is 0.0349. And lastly, it's very similar to the question above. We have what is the probability that these 64 students will spend a combined total between $703.59 and $728.45. I don't know why I said $703.59. $703.59, I'm sorry. So then first, since I do have to subtract both probabilities from each other, I started with the $728.45 divided by 64 students, which is the sample size, and then I got 11.3820, which is approximately 11.38. And then for the next, the other value of $703.59 divided by 64 students, I got 10.9935, which is approximately 10.99. And then putting it all together, I actually combined these. I didn't put them all in one cell. I just thought it'd be easier to read. I have the norm.dist, which is, since it is a normal distribution for the probability, I first started with the 11.38, which is the larger mean of the two. And then next, you would put in the 10.5, which was the original population mean, then 0.375, which is the sample standard deviation, and then true, because again, it's cumulative. And then we subtract that whole giant number by the normal distribution probability for $703.59. So we started with 10.99, which was the sample mean, given that amount, and then 10.5, which was the original population mean, and then 0.375, which was the sample standard deviation, and again, true because it is cumulative. And then therefore, just putting these all together, this is when I put it in Excel. Right here we have 0.9905, and we subtract that by 0.9043 to get 0.0862. Therefore, the probability of the 64 students, that the 64 students will spend a combined total, or spend combined between $703.59 and $720.45 is 0.0862 for the probability. Thank you so much, Professor. Have a great year. Thank you for everything. Stay safe, and I hope to see you again. Have a great day.